Motion appears continuous, yet under strict reasoning, it cannot be completed. A moving body must first cross half the distance, then half of what remains, then half again. This sequence does not terminate, but the motion does. The contradiction does not arise from observation. It arises from the structure used to describe it. This is before logic, a history of rules before they were written. These arguments are attributed to Zeno of Elea, active in the 5th century BCE. The original texts do not survive. What remains is preserved through later accounts, primarily in Aristotle and subsequent commentators. The formulations are reconstructed, and some variation in interpretation remains. The arguments operate under a specific condition. They assume that space can be divided and that time can be treated in relation to that division. From this, they examine whether motion can be described without contradiction. The difficulty does not emerge immediately. It appears when division is extended. One formulation considers the traversal of a distance. A body begins at one point and moves toward a destination. Before it can arrive, it must first reach the halfway point. Before that, the quarter distance. Before that, the eighth, and so on. Each step introduces a smaller interval that must be completed before the next begins. The structure does not terminate. No final interval appears. At every stage, further division remains possible. The number of required steps is not finite. The motion, however, is observed to complete in finite time. This introduces a constraint. A process defined as an infinite sequence must correspond to a finite outcome. The description and observation do not align under the same structure. The contradiction is structural. It does not depend on speed or the size of the distance. It depends only on the assumption that the path can be divided without limit, and that each division corresponds to a required step. The argument does not state that motion fails. It states that the reasoning used to describe motion produces inconsistency when applied without restriction. A second formulation examines pursuit. One body begins ahead of another. The trailing body must first reach the position previously occupied by the leading body. During that interval, the leading body advances. The trailing body then attempts to reach this new position. Again, the leading body has moved. The process repeats. Each step reduces the gap but introduces a new interval that must be traversed. Within the structure of the argument, the trailing body must always reach a prior position before progressing further. This generates an unending sequence of intervals. The gap decreases, but the sequence does not terminate. The observed outcome, in which one body overtakes another, is not denied. The argument shows that the structure used to describe that outcome cannot produce completion without contradiction. A third formulation shifts from extended intervals to instantaneous states. At any given moment, an object in motion occupies a space equal to its own length. Within that moment, it does not change position. If time is treated as a sequence of such instants, each without duration, motion must be constructed from positions in which no movement occurs. This introduces a second constraint. Motion must emerge from elements that do not contain motion. The argument does not establish that time is composed of indivisible instants. It examines the consequences if time is treated in that way. The result is that motion cannot be assembled from static components without additional structure. Across these formulations, a consistent pattern appears. Each argument isolates a specific assumption: infinite divisibility, sequential completion, or instantaneous time. When applied without modification, these produce results that cannot be reconciled with observed motion. The paradox is not located in the world. It is located in the relationship between assumptions. Within the intellectual context of Eleatic philosophy, these arguments are associated with a broader position attributed to Parmenides. Surviving interpretations suggest that change and plurality were treated as problematic under strict reasoning. Zeno's paradoxes operate within this context as a form of constraint analysis. They do not introduce new models. They test the stability of existing ones. The arguments show that commonly accepted descriptions of motion rely on assumptions that cannot be maintained simultaneously without inconsistency. The historical record does not preserve Zeno's exact formulations. The arguments are transmitted through later sources, including Aristotle, Simplicius, and others. These sources present the paradoxes in slightly different forms, and the extent to which they reflect the original structure remains uncertain. Some interpretations emphasize infinite divisibility. Others focus on the treatment of time. Others examine sequential dependency within the arguments. This variation does not eliminate the constraint. It indicates that the paradox arises from multiple interacting assumptions rather than a single definitional choice. The difficulty persists because it does not depend on empirical correction. Increasing measurement precision does not resolve the contradiction. The paradox arises before measurement, within the structure used to interpret measurement. This distinguishes it from observational error. It is not corrected by improved instruments or refined data. It requires modification of the conceptual framework. The paradox does not deny motion. It denies that motion can be described without contradiction under these conditions. This distinction becomes important in later developments. Mathematical treatments of motion eventually introduce the concept of limits. Infinite sequences are treated not as completed collections of steps, but as processes that approach a value. Under this framework, an infinite number of subdivisions can correspond to a finite result. The total distance can be expressed as the sum of a converging series. This resolves the contradiction within that system. However, this resolution depends on concepts not available in the original context. The distinction between potential and actual infinity, formalized later in Greek mathematics and developed further in early modern analysis, provides a way to treat infinite division without requiring completion of an infinite sequence as discrete acts. These distinctions are not present in Zeno's arguments. The paradox remains valid within its original assumptions. The historical significance of these arguments lies in the constraint they impose. Any system that permits indefinite division must also provide a structure in which processes defined over those divisions can be completed without contradiction. This requirement does not emerge automatically. It must be constructed. The paradox, therefore, establishes a boundary condition for reasoning about continuity. It shows that continuity cannot be assumed as a simple extension of observation. It must be defined in a way that remains stable under division. This requirement extends beyond motion. Any system that operates over continuous or indefinitely divisible domains must address how finite outcomes arise from infinite processes. This includes not only physical movement, but also later developments in mathematics, probability, and computation. The difficulty identified by these arguments does not disappear. It is absorbed into more complex systems that incorporate additional structure to prevent contradiction. Zeno's paradoxes remain a reference point because they isolate the problem in its simplest form. They do not provide a solution. They establish a constraint that later systems must satisfy. Motion can be observed without difficulty. It can be measured, predicted, and utilized. Describing it without contradiction requires a framework in which division and completion coexist without conflict. At the time these arguments were formulated, such a framework had not yet been constructed. The result is a persistent tension between observation and description. This tension marks a transition in the treatment of motion. Movement is no longer treated as a direct feature of experience. It becomes a problem that requires formal structure. The requirement introduced by these arguments remains active. Systems of reasoning must remain stable when their assumptions are extended. When division is applied repeatedly, the system must continue to produce results that can be completed within its own constraints. Zeno's paradoxes demonstrate that this stability is not guaranteed. They define a point at which intuitive descriptions fail under formal analysis. In the next episode, we will examine the liar paradox, self-reference, and logical instability.